Before we come to our main topic, why 0 factorial equals 1, we first need to understand where factorials even came from and why mathematicians felt the need to invent them in the first place. Centuries ago, mathematicians were trying to solve problems related to arrangements and counting. Questions like, in how many different ways can objects be arranged, or how many possible outcomes can exist, started becoming extremely important in trade, astronomy, gambling, and later in probability and science. Imagine you have 3 different books. How many different ways can you arrange them on a table? You could place them as ABC, BAC, CAB, and several other combinations. Very quickly, mathematicians realized that as the number of objects increased, the number of arrangements exploded rapidly. They needed a shorter and cleaner way to represent these huge multiplications, and that's where factorials were born. A factorial simply means multiplying a number by all the positive whole numbers below it until you reach 1. So 5 factorial means 5 times 4 times 3 times 2 times 1, which equals 120. In simple words, factorials are mainly used to count possibilities, arrangements, and combinations. Today they are used everywhere, from probability and statistics to computer science, artificial intelligence, cryptography, and even quantum physics. Now, factorials seem perfectly logical to mathematicians. 3 factorial equals 6. 4 factorial equals 24. Everything followed a clean and predictable pattern. But then mathematics introduced something that felt completely absurd. It claimed that 0 factorial is equal to 1. And suddenly, everything stops making intuitive sense. How can nothing become 1? Shouldn't it be 0 instead? After all, 0 usually represents emptiness. So why would mathematicians across the world agree on something that seems completely backwards? To understand this mystery, imagine you are climbing down a staircase of factorials. Start from 5 factorial. We know it equals 120. Now look carefully at how factorials change as we move downward. If you compare 5 factorial and 4 factorial, you'll notice that 4 factorial is just 5 factorial divided by 5, because 120 divided by 5 gives 24. Similarly, 3 factorial is 4 factorial divided by 4. Then 2 factorial is divided by 3, and 1 factorial is divided by 2. A clear pattern appears. Every time we move one step downward, we divide by the number we just left behind. Here's the interesting part. Since 1 factorial equals 1, what should happen when we move one more step downward to 0 factorial? The pattern says we should divide by 1, and 1 divided by 1 is still 1. Suddenly, without forcing anything, the answer naturally becomes 1. But mathematics does not stop there. There's another way to think about it that feels even more surprising. Imagine multiplication as a machine. When you multiply numbers together, you are repeatedly changing a value. Multiplying by 2 doubles something. Multiplying by 5 increases it 5 times. But what number changes nothing in multiplication? The answer is 1. If you multiply anything by 1, it remains exactly the same. That's why mathematicians call 1 the identity of multiplication. Now think about factorials again. 3 factorial means multiplying 3 times 2 times 1. 2 factorial means multiplying 2 times 1. 1 factorial is simply 1. But what about 0 factorial? There are no numbers left to multiply. The multiplication machine has nothing to process. In mathematics, when there is an empty multiplication, the result is defined as the identity number of multiplication, which is 1. Still not convinced? Let's try a real-life example. Suppose you have 5 different books, and someone asks, in how many ways can you choose 0 books? At first, it sounds silly, but think carefully. There is actually exactly one way to choose nothing, by choosing nothing at all. Not 2 ways, not 0 ways, just one valid possibility. And many important formulas in probability and computer science depend on this idea working correctly. One of the most famous formulas in mathematics is combinations. If 0 factorial were not equal to 1, this entire formula would start breaking in situations involving 0 choices. Large parts of probability theory would stop making sense properly. So in the end, 0 factorial equals 1 is not some random rule invented by mathematicians just to confuse students. It appears naturally from patterns, from the logic of multiplication, and from the deeper structure of mathematics itself. What first looks impossible slowly turns into something unavoidable. And that's one of the most fascinating things about mathematics. Sometimes the strangest answers are actually the only answers that make the universe of mathematics stay consistent. If you enjoyed uncovering the science behind this everyday mystery, subscribe to Curiosity Compass for more fascinating explanations about the world around us.